सुरू आहे का? Good morning, friends. Good morning to everyone. Be ready for today's session of Science.1. Good morning. Ushal Patil, Vedika, Jayesh, all are joining. Good morning. Be ready. Check your internet connection. Be ready with your textbook of Science.1. Yes, many are joining. Shivani, Prachi. Yes, okay. Yes, all are joining. Are you ready with your textbook? And you must have your textbook, and we are going to study today the topic which is given on page number 54. We are going to study the topic which is given in our book on page number 54. So keep your textbook in front of you and see page number 54. Page number 54 of a book Science. Are you ready? Tell me, are you ready? Can I start? Yes, many are joining. Yes. Good morning to everyone. Now, dear student, in a previous session, in a previous lecture, in the last week, what we studied in the starting, I am going to revise that topic so that you must know what we studied till now and what we are going to study today. So I am repeating. I am doing some revision of that topic which we studied in the last week. What we studied? We studied some important concept of the lesson effects of electric current. Many important concepts we studied, and first we studied heating effect of electric current. What is heating effect of electric current? When current passes through the conducting wire, through a conductor, the temperature of conductor increases, and how much the temperature will increase, that depends on the resistance of the conductor. Resistance of the conductor. If the resistance of the conductor is low, then less amount of heat is created. And if the resistance of a conductor is high, then that conductor creates more heat. And why heat is generated due to the resistance, that you studied in the last standard, in the 9th standard. What is main reason? If the resistance is high of that conductor, means when current passes through the conductor, the number of collisions between running electron and atoms and molecules are large in number. As the collision increases between the electrons, running electrons, and atoms and molecules present in the metal, heat increases. Collision is the main reason for the increasing or for the production of heat in a conductor, and this is called as a heating effect of electric current. In short, when current passes through a conductor, heat is generated. This is called as a heating effect of electric current in short. Again, in the last week, what we studied? What is magnetic effect of electric current? What is magnetic effect of electric current? And magnetic effect of electric current means when current passes through the conductor, there is a production of magnetic field around the conductor. Magnetic field is created due to the current passing through the conductor. This effect of production of magnetic field around the conductor due to the current is called as a magnetic effect of electric current, that we studied in the last week. Again, what we studied? We studied one important topic of board exam. That law always come for 2 or 3 marks in board exam. What was that? Tell me, what was that? What was that law that we studied in the last week? Important law, I told you. What was that law? Related with the direction of current and direction of magnetic field. Tell me answer. Arun Shinde, Madhura, tell me answer. Which law we studied? Yes. Jagruti is giving correct answer. Right hand thumb rule. Then Majid, again Siddhi, right hand thumb rule. Yes, dear student, you all know that we studied, and remember again, it is very important concept of this lesson. And that will definitely give you 2 or 3 marks in the board exam. Yes, right hand thumb rule. What is right hand thumb rule? Yes. Now concentrate on the board and concentrate on my speech, my lecture. I am repeating as it is important. What is right hand thumb rule? Imagine that you are holding a current carrying conductor in your right hand such that, like this, I am drawing the diagram. Imagine that this is a current carrying conductor and this conductor is placed in your right hand. This conductor you are holding in your right hand like this. I am showing in the diagram. This is your right hand. This is your right hand. And this is the current carrying conductor. And what is right hand thumb rule? This is thumb and these are the curved fingers. Right hand thumb rule is, if the thumb denotes the direction of electric current, that is denoted by I. If thumb denote the direction of electric current, then the remaining fingers, curved fingers around the conductor shows the direction of magnetic field produced due to the current passing through the conductor. Means, if this is the direction of electric current, so this is the direction of magnetic field. Direction of the magnetic field produced by current carrying conductor. This is direction of magnetic field. This is very important law. So, I am repeating, and these all 3 topics we studied in the last lecture, in the last session, in the last week. And now the next topic, which are also very important, and this is a very important or a basic of a branch of a science, subject of a science, that is physics. As this is very basic, you will need this in different competitive exams and different entrance exam after 12th standard. You are studying in 10th standard, you are studying in the 10th standard, but these topics are so important related with the physics that these topics you will need in future after 12th standard in different entrance exam, different competitive exams. So, remember these topics, this concept, these are very basic concept, and never forget these concepts, these are very important. These 3 concepts we studied in the last week. Again we studied with different instrument, equipment, electrical equipment that run on the heating effect of electric current. What were that? And that are, now we can also show that are electric bulb. Electric bulb is a very simple example of a heating effect of electric current. When current passes through the filament of the bulb, that filament becomes very hot. As the filament becomes very hot, it emits light. This is a basic principle of electric bulb. And on this principle, conversion of electric current into the heat, electric bulb works. And its filament is made up of which metal? Tungsten. Why tungsten is used in an electric bulb? Because the melting point of the tungsten and the resistance of a tungsten is very high. So, after passing the electric current, it becomes hot and emits light. And emission of a light is the main function of an electric bulb. That also we studied. Another example, another thing that we use in our house that works on the heating effect of electric current is fuse, electric fuse. And that fuse is also very important, as fuse protects very valuable equipments, electrical equipments in our house from high current coming in our house due to any fault, due to any accident. If large current enters in our house, it is stopped by a fuse, because in the fuse the wire which is used is of a substance having very low melting point. Very low melting point. As the low melting point, when a large current passes through the conductor, or we can say wire which is fitted in the fuse, it melts easily and speedily. And as it melts quickly, it stops the high current. And as the high current is stopped, that fuse protects very valuable instrument like TV set, like AC, like fridge, like music system, like geyser, mixer, grinder. Many electrical equipment that we use in our house is always protected by the fuse. And instead of a fuse, now during these days, a new technology, miniature circuit breaker, MCB are there. The function of the MCB and fuse both are same, but these MCB are advanced, and that also protects us from electric shock. That protects us from electric shock. Due to the MCB, our valuable instruments are protected, and we are also safe from electric shock. This is also a part of a heating effect of a electric current that we studied in the last week. And now, dear student, we are going to study today's topics, which are also important. So, make concentration on my speech and on the board. We are going to take next topic, and that is magnetic field produced magnetic field due to current in a solenoid. Magnetic field produced due to the current in a solenoid. One Rajendra Chaudhary asking, page number किती आहे sir? Page number किती आहे sir? You must ready with your textbook when our session starts. Now we are taking these topics which are on the page number 54. 54, solenoid. Yes. In this title, magnetic field due to a current in a solenoid. First you must know what is solenoid. You must know what is solenoid. Then what is solenoid? Solenoid is a winding. Solenoid is a winding that we see in the electric fan and in many type of motors. Rotating motor of fan, grinder, mixer. At many places this solenoid is used. Solenoid is the winding of a coated wire on a soft iron. on a soft iron. On the soft iron, a wire, very thin wire with a coating is wounded. Many turns are there, and that many turns of a coating wire on a soft iron is called as a solenoid. These solenoids are used at very many in very electrical equipments. These solenoids are used. Solenoid. Our topic is how magnetic field is produced due to the solenoid. In a solenoid, when current passes, this is called as a conducting wires with a coating, and for the current, source of current is provided. This is plug key, and this winding is turned on a soft iron. If you will see a electric fan in an open condition, then you will find solenoid in that fan. In any type of the motor, rotating device, rotating equipments, mixer, grinder, fan, water pump, all contain solenoid. All contain solenoid. Yes, what is there? A copper wire with resistance coating wound in the chain of a loops is called as a solenoid. Yes, correct. Who is there? Manish Gauri. Yes. Many turns are there of coating wire wounded, and so that is called as a winding. In a simple language, in a market, we always listen this word. What is that? Winding. Winding means many turns are there of a coating wire wounded and solenoid is prepared. And now our topic is how magnetic field is produced in the solenoid. See, how magnetic field is produced when the key is closed and current passes through the coil or winding due to the magnetic effect of electric current. Magnetic lines of force are produced. Magnetic lines of force. These are the magnetic lines of force. And in the last lecture, we studied different properties of magnetic lines of force. Magnetic lines of force. And what are different properties of magnetic lines of force that we studied? The magnetic direction is like this. Magnetic lines of force are away from each other, means they never intersect each other, they never cut each other, they are separated from each other, and these are invisible lines of force, magnetic lines of force, invisible, that we cannot see with our eyes, and due to that magnetic lines of force, magnetic field is produced. Magnetic field is produced when current passes through the conductor, and in this way magnetic field is produced when current passes through the solenoid. When current passes through the solenoid. Yes, this is very simple concept. How the magnetic field is produced? When current passes through the solenoid. And I am giving 1 or 2 minutes. If you are having any question related with this solenoid and magnetic field produced in the solenoid, ask questions. Dear student, now the time for questions. Ask me question related with this topic. Magnetic field produced due to the current passing through the solenoid. Ask questions. Yes. Now the time is for questions. Time, ask me question, otherwise I will take next topic. Any question? Or shall I take next topic, next concept? After this, which is given on the page number 55 in your book. In the textbook, our next topic is on the page number 55 after this topic of a solenoid. Yes, no question? Yes, Nikhil Gujarati is asking one question. Why only copper wire is used in the solenoid? Why only copper wire is used in the solenoid? This is a question of Nikhil Gujarati. Nikhil and dear students, why copper wire is used in the solenoid? It is very simple, because we need to use good conductor in the solenoid, and copper is a good conductor of electricity. Copper is used in the electricity, conductor of electricity, so it is used in the solenoid. And not only copper, at some places another conductor like aluminum is also used. And where to use copper as a conductor in a solenoid, in the winding, or where to use the aluminum in the solenoid or in the winding, it depends on the cost of equipments. If you are going to purchase a fan in the market of a copper winding or copper conductor used in the solenoid, then the cost of fan will be more. And if you are going to purchase a fan having a solenoid in which the aluminum wire is used as a conductor, the amount will be less. It is obvious, it is natural, because in the market the cost of copper is greater than the cost of aluminum. But then you will ask, which winding or which fan we have to take, which motor we have to take, which is in which the copper is used or in which the aluminum is used. If the copper wire is used as a conductor, it will works, that fan will work properly, and you will take less electric current. That will save our money. So the copper wire or copper winding is good for this purpose. There, next question. Nayan Bhatt is asking, what is the direction of the magnetic lines? Magnetic lines of force. That magnetic lines of force, look at here. If magnetic field is produced, this end north pole, this end is the south pole, and we studied about the magnetic lines of force, always starts from north pole and goes toward the south pole. This is the direction of magnetic lines of force. Magnetic lines of force. What is direction? Nayan Bhatt, your question, and answer is, the direction of magnetic lines of force is from north pole to the south pole. This is the direction of magnetic lines of force. Then I am going to take next question, that is, Rajendra Chaudhary, what do you observe? What do you observe means what? What do you observe? It is not a question. Ask question properly. Yes, Nayan Bhatt, your point is clear. What is the direction of magnetic lines of force? It is from north pole to the south pole. And again, keep in mind, the magnetic field produced by solenoid is just like a magnetic field produced by a bar magnet. What I am telling? The magnetic field produced by the solenoid is similar as the magnetic field produced by a bar magnet. And we know, in a bar magnet, the magnetic lines of force which are invisible starts from north pole and ends on the south pole. And the number of lines of force are greater at the two poles, north pole and south pole, and they are less in the middle. And so we know, in case of a magnet, the magnetic power or magnetic field is greater at the poles and less in the middle. This is reason. What is reason? It depends on the number of magnetic lines of force, and they are crowded at two poles, less in the middle. Next question. Why copper wire is resistive coating? Yes. Question of Jayesh Patil. Jayesh Patil is asking, why copper wire is having resistive coating? Dear student, if resistive coating is not there, imagine, then what will happen? That winding, that turns, number of turns will connect with each other as there is no coating, as there is no resistive covering. And then what will happen? The length and the number of turns will decrease. And as the number of turns decreases in the solenoid, means if the winding decreases, what will happen? The less amount of magnetic field is produced, less amount of magnetic field. And so there is a coating on the conducting wires, like copper coating is done, and it is very thin wire. It is very thin wire having a coating to produce more magnetic field, and to avoid short circuit. A resistive cover is on the wires. This is main reason. Yes. Now I am going to take next topic, and that is force acting on a current carrying conductor when it is placed in the magnetic field. And it is very important point. And on this principle, on this concept, many electrical equipment works on this principle. That is what? Force acting on current carrying conductor current carrying conductor in a place in the magnetic field. This is our next topic. What is our new topic of this lesson? Force acting on a current carrying conductor which is placed in the magnetic field. Means what? Its title suggests force acted on a conductor carrying current when it is placed between the magnetic field. That we have to study how it is produced, why it is produced. And for this, very simple one electrical circuit is there, like this, current carrying conductor, and here for current, a source of electric current is provided. To stop or start current, electric key is provided. This is the direction of flow of current. This electric circuit. And we studied in the last lecture, in the last week, when current passes through the conductor, magnetic field is produced around the conductor. We cannot see with our eyes, but it can be tested. A magnetic field is produced around the conductor, and the direction of magnetic field produced in the conductor is according to the right hand thumb rule that we studied. And if current is passing, as current is passing, magnetic field is produced around the conductor, and if such conductor is placed in the another magnetic field produced by another magnet, what will happen? If such a conductor which is producing magnetic field around it due to the current passing through it, and if it is placed in the another magnetic field produced by magnet, what will happen? What happens when it is placed on the another magnetic field of another magnet? I am showing this magnet or shoe magnet, and this we can say like this. This conductor is now passing through the magnet. Magnet it is passing means through magnetic field that conductor is passing, and that conductor is also producing magnetic field according to the magnetic effect of electric current. This conductor creating magnetic field, it is placed in the another magnetic field produced by the magnet. Then what is the principle? A force is exerted on the conductor. force is exerted on the conductor. And why the force is exerted? Again we studied. What will happen? When two similar magnetic poles are near to each other, they are not near to each other, what will happen? It will repel each other. And when two opposite poles of magnet are near to each other, what will happen? They attract each other. You studied these very basic properties of magnets. In the opposite poles come near to each other, force, and the magnetic field is produced by the conductor and it is placed in the another magnetic field, and it is placed on the another magnetic field. So the force is exerted on current carrying conductor. This is very basic and very simple thing. What will happen if the current carrying conductor is placed in the another magnetic field? What will happen? What will happen? Force is exerted on the conductor. And now, dear student, three things are there. Which three? Electric current. Due to the electric current, magnetic field is produced. And due to the magnetic field is produced, a force is exerted on the conductor. Three things are important here. First is current is passing. Second, magnetic field is produced by the current carrying conductor. And third, a force is exerted on the conductor. And as these three things are there, what are the directions of these three? What are the directions of these three means? What is the direction of electric current? What is the direction of magnetic field? And what is the direction of force acting on the conductor? And this is again a very basic. As we studied right hand thumb rule to check the direction of electric current and magnetic field. Another important law. Now we are going to study very important law. It is given on the page number 55 in your textbook. So in the textbook, what is that? Fleming's left hand rule. Fleming's left hand rule. In the last week we studied right hand rule, but that was right hand thumb rule. Right hand thumb rule that we studied for the checking of, to check the direction of electric current and magnetic field produced. Now the next similar law to check the directions is Fleming's left hand rule. Fleming's left hand rule. And Fleming's left hand rule is related with three directions that I am telling again. Which direction of electric on the conductor? That three things we can check by using Fleming's left hand rule. Then what is Fleming's left hand rule? It is very important. That will give you 2 or 3 marks in board exam. So keep this in mind. It is very important. And what is Fleming's left hand rule? That we are going to check now. What is that? Imagine that in your left hand all three fingers are like this, Look at on my hand also. This is my left hand and my three fingers, thumb, forefinger and middle finger, or this finger is also called as the index finger. Three fingers are there. Which three fingers? Thumb, then forefinger and middle finger. And three directions are given by using this left hand, and that is called as the left hand thumb rule. And what is the law? As the middle finger shows the direction of electric current, and these three fingers are perpendicular to each other. As the middle finger shows the direction of electric current, then our forefinger shows the direction of magnetic field, and thumb denotes the direction of force acting on the conductor. Three directions we are checking with the help of left hand rule. What are that three directions? As current passes in the direction of a middle finger, then magnetic field is produced in the direction of a forefinger and force acting on the conductor is in the direction of the thumb. This is called as a Fleming's left hand rule, related with the three directions: direction of current, direction of magnetic field, direction of force acting on the conductor. Yes. There is a simple rule relating these three directions. This is called as Fleming's. That I am telling. Manish Gaudi, that I am telling. What I am telling? Left hand rule. Keep your left hand such that all three fingers, thumb, forefinger and middle finger, perpendicular to each other, and as the middle finger shows the direction of electric current, forefinger will show the direction of. And now, dear student, we studied is Fleming's left hand rule. Fleming's left hand rule. In figure, we can denote as these three fingers are perpendicular to each other, and if this middle finger shows the direction of current, then the forefinger will show the direction of magnetic field, and this thumb will denote the direction of the force acting on the conductor. This is a very simple and basic concept of the Fleming's left hand rule, which is used to check the direction of the force acting on the conductor. So, dear student, read page number 54, 55 from book, and if you will have any confusion, any difficulty, any question,